Good morning friends. Today in this video we'll see how to sort an elements using bubble sort. Bubble sort is a technique in which we are comparing the adjacent elements and swapping their positions if they are not present in either ascending order or descending order. We can implement any type of ascending or descending order in this mechanism. This algorithm is called as a syncing or comparison algorithm because at the end of every pass the either highest element or the lowest element will goes to the intended position. This algorithm works efficiently for the small sets of the data. Whenever the large sets of the data is coming, automatically it will take more time to compare. We'll see this bubble sort algorithm with an example. Initially, we are comparing the first two elements, that is 5 and 4. So because 5 is greater than 4, I want to have the elements in ascending order. So 5 is greater than 4. So I am swapping these two elements. 5 is coming to the fourth position and 4 is coming into the 5 element position. 4 and 5. Next I am comparing these two elements 5 and 6. Because 5 is less than 6, I am leaving the elements like that. Next I am comparing 6 and 2. 6 is greater than 2. So swapping of the elements is happening and 2 and 6 will be coming. Next 6 is compared with 3. Because 6 is greater than 3, I am swapping the two elements and it is coming as a 3 and 6. Next I am comparing 6 with 1. Because 6 is greater than 1, I am swapping these 6 with the 1. At the end of the pass 1, the largest element is coming to the its own position, that is its position, the ending position, because it's an ascending order. If it is a descending order, the smallest element will come to the starting position. So now we'll go for the next pass. In the next pass, once again the same process is repeated. The first two elements 4, 5 are compared. There was no change. So elements are like that only. Next 5, 2 are compared because 5 is greater than 2. 5 is swapped with 2. Next, I am comparing these two elements 5 and 3 because 5 is greater than 3. The 5 and 3 are swapped. Next, I am comparing 5 and 1 because 5 is greater than 1. The elements are swapped and the 5 comes to its position. So at the end of the second pass, the second largest element came into its position. So similarly, I am implementing for the third pass. In the third pass, the same process is repeated. 4 is compared with 2 because 4 is greater than 2. We are swapping 4 and 2, it becomes 2, 4. Next 4 and 3 are compared. 4 is greater than 3, so it is swapped. Next 4 is compared with 1, so because 4 is greater than 1, so it is swapped. So 4 came to its position. Next in the pass 4, these two elements are compared. There was no change. Next 3 and 1 are compared because 3 is greater than 1. They are swapped and 3 comes to its position. Next in the fifth pass, 2 is compared with 1 because 2 is largest than 1. So both are swapped, 1 and 2. Now only one element is there, so we are stopping at this position. Now if we see, in this particular mechanism, initially for the number of passes, we are considering the I and it is varying from 0 to n minus 1. Whenever the I value is 0, I am comparing the j value from 0, 1, 2, 3, 4. So that means I am comparing a of j and I am comparing a of j plus 1. Initially j value is 0. So a of j is compared with a of j plus 1. That is a of 0 and a of 1. Next j value is incremented. Now j value is 1. So a of 1 is compared with a of 2. Next j value is 2. A of 2 is compared with a of 3. Similarly, a of 3 is compared with a of 4 and a of 4 is compared with a of 5. That means the j value is varying from 0 to 4. In the second pass, the I value is becoming as a 1. Now see here, once again the j value is starting from 0. A of 0 is compared with a of 1. A of 1 is compared with a of 2. Like that we are comparing A of 3 with A of 4. So whenever the I value is 1, the J value is varying from 0 to 3. Now if you see when I value is equivalent to 2, once again we are repeating the same process. Like that in the past 5 I value will become as a 4. At that time J value is 0 to 0. So only A of 0 is compared with A of 1. Now if you see this particular relation that we are having, whenever the I value is 3, the J value is varying from 0 to 1. How this particular 1 is coming? This 1 is coming, the total number of elements is 6. 6 minus 1, that is 5, and we are taking this particular 3. That means the J value is varying up to n minus I minus 1. That means whenever the I value is equivalent to 3, it is comparing up to J is less than 3 minus 6 minus 3 minus 1. That is J is varying from 0 to 2. That is J value is equivalent to 0, J less than 2, J plus plus is the concept that we are considering. When we are considering the I value as a 2, see here, this we are writing in a loop in such a manner that J equal to 0, J less than 3, J plus plus we are writing. Because the J value is varying from 0 to 2. This programmatically we are writing as for J equal to 0, J less than 3, J plus plus. That means we are writing the general formula as for J equal to 0, J less than n minus I minus 1. That is 6 minus 2 minus 1. That is 3. That's why for J equal to 0, J less than 3, J plus plus we are writing. If you see the algorithm implementation of this one, initially we are reading the value n. N is the size of the array. Then we are reading the array A elements. Then I am changing the I value from 0 to n minus 1. And I am varying the J value from 0 to n minus I minus 1. And I am comparing A of J and A of J plus 1. If A of J is greater than A of J plus 1, I am swapping this one. At the end, we are displaying the. Now we'll see the programmatical implementation of this one. Initially, we are taking some array. I have taken array with size of 20. And for the size of the array, we have taken n. And temp is a variable that we are using for swapping purpose. And I and j are the variables that we are using for the for loop. At first, I am reading the size of the array. I am reading the size of the array by using the printf and the scanf statement. Then I am reading the elements of an array. The elements of the array can be read by using for I equal to 0, I less than n, I plus plus, scanf percentage d, ampersand a of I. Then I am implementing the original logic of the bubble sort. The I value is varying from 0 to n minus 1 because last element need not be sorted because the left out element is the last element. It is the smallest element in our thing. And in every loop, the J value is varying from 0 to n minus I minus 1. So I am comparing A of J with A of J plus 1. If A of J is greater than A of J plus 1, then there is a need of swapping. The swapping logic we are implementing by using temp equal to A of J equal to A of J plus 1, A of J plus 1 equal to temp. At the end of all the passes, I variable is specifying the number of passes that we are having. If 6 elements are there, 5 passes we are performing. If 10 elements are present, 9 passes we are placing. And after completion of the sorting, I am displaying the elements of an array. And if you see the complexity of this particular bubble sort algorithm is having the worst time complexity of order of n square. And it is having the best case time complexity of order of n, and average time complexity is order of n square, and the space complexity is order of 1. These are the complexities of the bubble sort algorithm. Thank you.